Good morning to everyone. My name is Dr. Deepak Paliwal, working at Gitani Institute of Technical Studies, Mechanical Engineering Department. And in this video lecture, I will be discussing on correlogram. Actually, this is a topic which comes under time series analysis, and time series analysis comes under the subject data analytics. Data analytics is a subject in mechanical engineering branch. The students are learning this subject in the second year, fourth semester. So let us discuss about the topic correlogram. In my previous lecture, I have explained that what is autocorrelation. So whenever we have time series, then based on that time series, we can develop a table which is based on autocorrelation calculation. So if you remember this example I have taken, and in this example we have calculated the value of autocorrelation, and here this k is the level of autocorrelation, and you can consider it as 0, 1, 2, 3, 4, and if you wish you can go to 5 level also. So at each level you need to do autocorrelation, and based on that whenever you do the complete exercise, you will get the value of autocorrelation corresponding to each value of k. So here let us say that for whenever there is a the level of 0 is considered, then that means the data set is same. So same data set is being when it is correlated to again with the same data set, then definitely you will get the value of correlation equal to 1, because the data set is same only. But once you go to the level 2, when you skip the first value in the data set, then you will get another value of autocorrelation. Likewise, you can skip 2 values, you can skip top 3 values and top 4 values, and every time you can have the calculation of autocorrelation, and in every calculation you will find a new value. Okay, so you can put that value and prepare a table. So once this table is prepared, then you can have the correlogram diagram. Okay, so what is this correlogram diagram? It is a plot, right? So it is a plot between k number. I already explained that what is this k number. K number is the level of autocorrelation. So it is a plot between k number and corresponding autocorrelation value, and here we are representing autocorrelation value as rho. So let us discuss about this plot. So this plot, again, this is a 2D plot having two axes. One axis is x-axis and one axis is y-axis. In x-axis, what we can do, we can represent the value of k number. Okay, so k number, as I said, it can be 0, 1, 2, 3, 4, based on the table which just now we have seen. Okay, so based on that table, you just mark 4 points on the x-axis at equal distance. So once you mark these points on the x-axis, then after you start plotting the value of rho. This is the autocorrelation value. So autocorrelation value, when the value of k is equals to 0, then we know that this value will be equal to 1. Okay, accordingly, when we have taken the value k equal to 1, when we have taken the value k equal to 1, that means this value, according to our calculation, we obtained minus 0.72 value of autocorrelation, because the value is in minus. So this, you can see I have marked a point over here. This is the negative side of the plot. Okay, and here you can see at this particular point it can be minus 0.72. So this can be minus 0.72. So based on that table you can mark this point. Now when you go to the next level, 2 or 3 or 4 side by side, you will get a plotting like this. So this is the general plotting that you can get, and this plotting is actually known as correlogram. So what is the physical significance of this correlogram? Why we are making this correlogram? By making this correlogram, we will get an idea about the nature of data set, and let us understand this, how we can find the nature of data set. One thing is, here there is a range, and this range is 1.96 upon under root n. So this is the upper limit, and same calculation when you do, then you put the minus sign over here, you will get the lower limit. So you have this dash line is representing limits between which this data is moving, or this data is being captured. Okay, so there is a range. So here it is written range between 1.96 upon root n to minus 1.96 upon root n. So all the data set is trapped in between these two limits. Okay, if this thing happen whenever we have time series, and when we analyze those time series, and the data set gets trapped between the particular limits, then we can say that the nature of that data set is random in nature. Okay, so by looking at correlogram, we can identify the nature of data set. So once you get such kind of diagram, that is between the limit you get all the values, that means that indicates that the data set, which is the time series, is random in nature. Okay, so if the time series is random in nature, then all autocorrelation value falls in the range between 1.96 root n and minus 1.96 root n. So this is one thing. So correlogram is giving an indication that what kind of data set is there. Secondly, when the same thing you do, and if at some points, especially at the beginning, if the value of rho autocorrelation exceeds this value on both sides, okay, as you can see in this picture, these are the limits. While when we have a plot between the value of k and value of rho, you will get such kind of pattern. Here you can see at the beginning or close to the value of k, when the value of k is equals to 0, 1, 2, you will find that the value of autocorrelation is greater than this particular limit in both sides. And then finally, when you increase the level, you will find that the value gets decreases, and such kind of pattern you will see. Okay, so if you do the analysis and you find that this kind of pattern is appearing, that means the time series which is being analyzed is stationary in nature. Okay, I said time series is of two types, one is stationary and second is non-stationary. So when a time series is analyzed and through correlogram such kind of pattern appears, or such kind of plotting appears, that means the time series is stationary in nature. On the other side, if the time series is non-stationary in nature, then whenever you do the correlation calculation, you will find such kind of plotting. Here you can see these are the two limits, and the value of autocorrelation is always going out of the limit. Okay, it is not limited to the beginning part and then it is coming inside the limit. It will sustain for the entire range of value of k. Okay, here k is 0, here you may take it as 1, 2, 3, 4, 5. So you go at more and more level of k, more and more level of autocorrelation, you will find that these autocorrelation values are not coming into the in between the range. If this thing happened, then you can say that the time series is non-stationary in nature. Okay, so this is how in this example we have seen that how correlogram represents a time series, and how through the plotting of correlogram we can understand the nature of a time series is stationary or it is non-stationary. So let me give a simple definition of stationary time series. If the mean and variance of time series remains constant over a period of time, it is called stationary time. So two things are important: mean and variance. If they are constant over a time series, the time series is said to be stationary time series. When the mean and variance of a time series changes when measured at different time duration, it is called non-stationary time series. So this is all about time series analysis, autocorrelation, and correlogram. So through this we can understand what is the nature of time series for the analysis purpose. Thank you very much.